Okay. Can you simplify the denominator? Are there any perfect cube factors that you can remove from 16? Yeah. 16 is 8 times 2. So if we rewrite this, the cube root of 8 comes out as a 2. And what factor is left inside the radical? Also a 2. And so now, as you work through this, you can multiply by the fraction, a value of 1. It's going to have the same index, cube root, the same base, 2. Again, we need whatever the index is. In this case, it's a 3. We need 2 to be taken to the third power in order for that to cancel out of the denominator. So we have 1 to start with. How many more do we need when we rationalize? We need 2 more. Again, we need to maintain this value of 1. And so now, as we multiply across, the 2's cancel. So we get the cube root of, again, 2 squared, or 4. And then what's going to happen in our denominator? The cube root of 2 cubed reduces to just the 2. All right. Questions on that? Okay, let's add one more layer of complexity. All right, if you look at this problem, okay, so now we're dealing with a cube root. What do you recognize about the 9? It's a perfect power, right? Okay. Are there any perfect cube factors you can remove from 9? No. So we go to the next step, which is anytime you're thinking, or anytime you see radicals, you always need to see it in terms of their exponential form. So that's part of this simplify radical. Rewrite the number in exponential form or remove any perfect powers. So what is the exponential form of 9? 3 squared. Okay, so think of it in terms of 3 squared. We haven't manipulated the number, only the form of it. And now we can go to our next step, which is multiply by a value of 1. That value of 1 is going to have the same index, cube root, the same base. Now what is our base? Instead of 9, we simplified it into an easier to use number. Okay. And in order for our radical in the denominator to cancel out, we needed this base to be multiplied by itself a total of 3 times. We need 3 to show up 3 times. We had 2 to begin with, so how many more do we need? Just 1. So now when you choose to rationalize, you're going to rationalize by the cube root of 3 to the first. And then when you multiply across the top, you get the cube root of, or 2 times the cube root of 3. And in the denominator, what are we going to get here? The cube root of 3 cubed, the root and the power cancel, leaving just that base of 3. And does everybody see what we did there? And now, if you left 9, okay, and you used the same kind of rule that we did on the last ones, if you tried to rationalize by the cube root of 9 squared over 9 squared, you're still going to get the right answer. But what's going to happen is the number that's in your radical up here is going to be such a large number that it'll be difficult for you to simplify it, right? Because what you'd be looking at is the cube root of 81 in this case. You'd have to search through and find, are there any perfect cube factors from 81? Yeah, 27. So you could take that out and wind up simplifying it and all, but it winds up giving you much larger numbers, and sometimes there'll be numbers that are going to be very difficult to work with. Versus if you write it in this exponential form with the smallest base possible, that gives you real low numbers to work with. Everything that's very comfortable to do with calculating by hand. All right, let's go through one more example of this. Actually, let me use a different number. Okay, see if you can find it. what would you get if you simplified or rationalized this fraction? There's no perfect powers of 5 that you can remove, but you should recognize 36 is a perfect power. So what can we rewrite 36 as? 6 squared. So now when we rationalize, we're going to use a value of 1. The index will be the same, so 5th root. The base will be the same, so we're going to choose the base of 6. And now we want our total number, or the total powers, to be identical to the index, so we need a total of 5 6s. How many do we have to start with? We have 2 to start with, so how many are left that we need? 3. So we're going to take 3 6s. And what that allows us to do now is simplify across the top. 6 cubed is 216. Again, that's the highest one that you need to be familiar with. And then in the bottom, what are we going to get? Just the base of 6. The 5th root of 6 to the 5th. Power and index cancel, leaving that quantity. Again, it is very systematic, and it's if you understand that process and can identify any perfect powers, it'll simplify what you have to do. All right, what I'd like you to do here really quickly is on page 19. I want you just to really quickly attempt the first 3 problems from sample problem 14 on page 19. So when you look at this, again, root 5 doesn't simplify, so this is the basic rationalize. Multiply by a value of 1. Radical is square root. Base of 5. We need the total sum to be the index 2. We have 1 to start with, so we only need 1 more. So multiply across the top and get 1 times root 5. Across the bottom, just the base of 5. Okay. In the second example, again, it's simplified. So we're going to multiply both sides, top and bottom, by the same value. The index will be cube root, the base of 5. We need a total number of 5s equal to the index of 3. So we have 1 to start with. How many more do we need? 2 more. So when we multiply across the top, we get the cube root of 5 squared, which is 25, all over the cube root of 5 cubed, or again, if you follow this pattern, it'll always just be the base that comes out of the denominator. The final example. Here, again, no perfect cube factors out of the denominator, but you should recognize you can simplify this into an exponential form with a smaller base. Okay. And then we can rationalize. The root needs to be the same, cube root. The base needs to be the same, 5. And we need a total of whatever the index is, in this case, 3. We have 2 5s to start with. How many more do we need? Just the 1. So when you multiply across, you get cube root of 5, and in the denominator winds up being, again, just that base of 5.